Okay, here we go. Writing the equations of lines. Flip lesson number 4. All right, so we're being asked to sketch these two lines on the same graph and to see if we notice anything. So I'm going to take my graph. Apparently, I've already graphed them. So the red graph is showing this line right here, right? My y-intercept is -4. Why don't I use red? My y-intercept is -4. My slope is 2, up 2 over 1, up 2 over 1. So that's that line. This equation matches up with this graph. My y-intercept is 3. My slope is 2, up 2 over 1. So what do we notice? Well, the first things we notice is that these two lines are parallel, right? They are parallel. Parallel lines will never ever intersect, right? They'll never touch each other. And the reason why they're parallel is because they have the same slope. So if I'm writing this down, make sure you're writing it down on your paper. So here we notice that both of these equations had the same slope, right? The slope of 2. So it would make sense when we graph the lines that we would have two lines with exactly the same slope. And because they have the same slope, they are parallel. Okay, draw a line that is parallel to y equals 3x minus 4 and also has a y-intercept of 2. So we could go about this two different ways. The first thing is we could go ahead and graph this line. We could see that it has a y-intercept equal to -4. 1, 2, 3, 4. We can see that it has a slope equal to 3. So we would go up 3, 1, 2, 3 over 1. 1, 2, 3 over 1. I want to try to get, I can draw a straighter line if I do more dots. Okay, not too bad. So we want to find a line, so a new line that's parallel to this and also has the y-intercept of 2. So our y-intercept of 2, I'm going to go to the y-axis and put a point, put a dot on 2. And we just learned that, or we were reminded that parallel lines have the same slope. So if I want to draw a new line in green that's parallel to the old line in blue, then I'm going to use the same slope. I'm going to use the slope equal to 3. So from this point, I'm going to go up 3, 1, 2, 3, over 1, and there we have it. So draw a line that's parallel to y equals 3x minus 4 and also has a y-intercept of 2. That's this line right here. Write the equation of a line that's parallel to y equals 1/4 x and has a y-intercept of 5. So here we're just writing the equation of the line. We're not graphing it. So what do we know about parallel lines? That's right, parallel lines have the same slope. So they're giving me an equation already. This is the old equation, and now we want something new. The new equation has to have two things. It has to be parallel to the old line, and it has to have a y-intercept of 5. Since we know that parallel lines have the same slope, then our new line has to have the exact same slope as the line it wants to be parallel to. So that gives me 1/4 x. And of course, the new line also has to have the y-intercept of 5. So there we go. This is the equation of the line that's parallel to this old line and also has the y-intercept of 5. Now we want to draw a line. So now we're back to graphing. Draw a line that's parallel to x equals 0 and also goes to the point 3, 2. So we're going to do two things. The first step is we're going to sketch the line. So we're going to take this. I call them the old lines because they're given to us. So we're going to sketch x equals 0. Well, we know x, those are vertical lines. They go up and down. And since x equals 0 is right there It's going to be a straight up and down line. I know, isn't that funny? It's actually the y-axis. Another name for the y-axis is x equals 0. And that makes sense because every single point on this line, x equals 0, has x equal to 0. Every single point. That's why its name is x equals 0. All right, so that's our old line. So our new line, we want our new line to be parallel. So our new line has to be parallel to our old line and also include this point. So let's go ahead and graph the point. 3, 2 tells me that I'm going over 3 and up 2. There's my point. And so it would make sense that if we want to draw a line through this point that's parallel to the line x equals 0, this line will also have to be a vertical line going straight up and down. So there we have it. Our new line is parallel to our old line and goes through the point 3, 2. So now we're going to be given the line y equals 5x minus 2. And we're going to be given a point, 3, 4. We want to write an equation that's parallel to the given line. So this is my old line. We want to write a new equation. So the new equation for the new line has to have two things. So let's see. Let's keep reading. It has to be parallel to the given line. So my new line has to be parallel to this old line. And it has to go through the given point. And the given point is here. So let's see if we've got this straight. If we want our new equation to be parallel to the old equation, our new line to be parallel to the old line, we're going to take the same slope and say our new line will have the slope of 5. Our new line also has to include the point 3, 4. So I'll say plus, it has to include 3, 4. So let's think about this. We want to write an equation, and we want to write this new equation in y equals mx plus b form. We already know that the slope is 5, so we're halfway there, right? Do you remember how we always work to find the b? That's right. We've been working the last 2 classes making a table to remind ourselves that the y-intercept is the y value when x is equal to 0. And we notice that we don't have the point 1 comma something, nor do we have the point 2 comma something, but we do have the point 3 comma 4. We're going to use this table along with the fact that our slope is equal to 5 to figure out what our y-intercept is. Because the slope is 5, that means that as we are going down the table in the y column, we would be adding 5, right? But we don't want to go down the table. We want to go up the table so that we can figure out what our y-intercept is. So going up the table, we do the opposite of the slope. Instead of adding 5, we're going to subtract 5. So that means 4 minus 5 is negative 1. Negative 1 minus 5 is negative 6. Negative 6 minus 5 is negative 11. And there you go. B is equal to negative 11. Our y-intercept is equal to negative 11. So we just take that, and that becomes our missing piece in our new equation. Negative 11. So now what did we just do? We wrote a new equation that is parallel to our old line. That's why they share the same slope, because they are parallel to each other, and includes this point. And this point allowed us to use the long table and work backwards using the slope to get to our y-intercept of negative 11. So you can see that this new lesson is just building on our old lesson, right? Find the slope of the line y minus 4 equals 3x minus 2. So here's the deal. We can go ahead and spend the time, if we wanted to distribute the 3. Let's rewrite it. Let's distribute the 3. 3 times x is 3x. 3 times negative 2 is negative 6. Then we could add the 4. Remember, we did these when we were graphing, right? When we took the linear graph test, this is what we did. -6 plus 4 is -2. We put it in y equals mx plus b form, and then it's really obvious that right here is my slope. My slope is 3. But wait a minute, do we need to do all that work? Because if we don't need to do all that work, let's not do it. So hopefully you wrote that down because that's important to see. But we didn't actually need to do that work, and I'll tell you why. This equation is in point-slope form. And when it's in point-slope form, the number that is in front of the x, this number, is always the slope. So when we see a line in point-slope form like this, we don't have to do all of this work that we just did, because we can say, there's the slope right there. It's 3. Now, if you forget and you go ahead and distribute and put it into slope-intercept form, that's okay. You know what? You didn't waste too much time, and you're going to get the correct answer. But if you can remember, just identify that 3 is actually the slope. Whoops. All right, so the next problem is, given the line y minus 4 equals 3 times x minus 2, we recognize that. So this is our old line that they've given us. So given that line and the 0.15, write an equation that's parallel to the given line, the old line, that goes through the given point. So we're writing a new equation, and our new equation has 2 parts, right? We need to find both the slope and the y-intercept. Well, they gave us the slope, right? Our new equation is parallel to the given line. That means our new equation has 3 for the slope. Our new equation also has the given point, 1,5. So when we think about our equation, y equals mx plus b, we know we're halfway there. Our slope is 3. And our b, we're going to find our b by using our table. So we set up our table. We know that our y-intercept is the number that we get when x is equal to 0. And oh, this is our lucky day. Look what point they gave us. They gave us 1, 5. We don't have that many jumps to do we? So because the slope is 3, that means when we move down the table, we add 3. But we don't want to move down the table. We want to move up the table to find our y-intercept. So if we move down the table, adding 3, so we're adding the slope, we're going to move up the table, subtracting 3, doing the opposite. So 5 minus 3 is 2. Voila, 2 is my y-intercept. I'm going to bring that down. And look what we got. This line, this equation of a line that we wrote is parallel to the given line, the old line, as well as going through this point 1, 5. All right, I believe that's it. Thank you for joining me. We're going to work really hard practicing these and getting ready for the toughest test so far this unit. All right, thanks for joining me. See you in class.